Hey there, Year 11s. So this is exercise 14E, symmetry properties. This is probably one of to me, the most foundational exercise of them all. So you want to spend time to really understand the theory component here. So assuming that you have understood exercise 14A and 14B about the unit circle, we're now going to continue on a bit further with the unit circle as well. In every one of the examples I'm going to do, I'm going to refer back to the unit circle again. Okay, so let's have a look at this one here. We've got, as an example, we've got, let's see, in this unit circle here, notice they call it quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Notice that it's going in an anti-clockwise fashion. That's because the angle that we generally work with conventionally, positive angle, is anti-clockwise. So if I said 90 degrees, you would expect that starting from here, this is 0 degrees, and then you work your way towards anti-clockwise. This is 90 degrees, which brings you to this point on the circle. Okay, so that's 90-degree distance there, which in terms of radians, the distance is pi on 2. Okay, so just to remind you with the unit circle again, remember the distance is, the full distance around a unit circle is 2 pi. Half that distance would then land you here, which is at pi. So from here to here, that distance there is pi. So going around the circumference of the circle, coming to this point, that's pi distance. And again, to only go a quarter of the circle is half of that pi, which is why it's pi on 2. Okay, so we now know distance from here to here is pi on 2. Okay, so we call the first quadrant, okay, so the first 90 degrees quadrant 1 or Q1. Then we say, as you move into the next quadrant, which is the next 90-degree section, this is Q2, Q3, and Q4. Reason why you need to know the Q1, Q2, Q3, Q4 is because in each and every one of these quadrants, there are some special properties, which is what I want to teach today. Okay, so notice that, remember, and there's ways to memorize this. There's acronyms for it, but I don't prefer you learn. I prefer you don't learn the acronyms, but instead I want you to understand it from the unit circle perspective. So let's have a look at a point. I'm going to choose a point over here, right? That's a point xy on the Cartesian plane. What's interesting is that at this point, what we're going to be looking at is I'm going to ask you at this x value and then this y value, is the x and the y positive or negative? What you should notice here is that x is positive in this region and the y value is also positive in this region. Okay. Now, what's interesting is if you then have a look at each point around the circle, so if I chose this point over here, so same thing with this x value and the same y value. Notice that the x value is now on the negative side of the x-axis. So the coordinate here would then be negative x, but it's positive y. So you would say it's negative x, but positive y. And then if I chose another point, say in the third quadrant, so I'm going to draw the same x, and I'm going to say the y value is over here. Notice that it's negative y, and this point is also negative x. True, so in that region there, both x and y is negative, so I'm going to put negative and negative. And then the last point to focus on is this point over here. You would then say that's positive x, but negative y coordinate. So if I labeled it, it's positive, then negative. Now what's special is, do you remember, in the xy coordinates, I'm just going to highlight here, remember this coordinate in my previous video in exercise 14b, we knew that x and y, the x was represented by the cosine of theta. And same thing, y is the sine of the angle theta. Meaning that from the center of the circle out to that particular point, remember the radius is 1 because it's a unit circle, it has a particular x length and it has a particular y height, making it a 90-degree triangle, which looks like this. the angle that it makes, and this is 1, this is x, and this is y. Remember, I showed you that the ratio sine of theta back in SOHCAHTOA in year 9, you know, is opposite over hypotenuse, which works out to be opposite is the y value and hypotenuse is 1. That's why sine of any angle, okay, so whatever the angle is that you make, the sine of that angle, when you type on your calculator, you're actually just working out the y value at that point. So what this means is if we look at the quadrants again, look at the y values here. Sine, I'm going to use maybe in blue. Sine is positive. Cos is also positive, right? Then you go into the quadrant 2, notice sine is positive and the cosine, on the other hand, is negative. Then you go down here, notice this is now cos is negative, sine is negative. Cos is positive and sine is negative. So sine's negative, cos is positive, negative, negative. And what's interesting is where is sine positive? There are only 2 regions where sine was positive, 1 and 2. And it doesn't take a genius to figure this one out because clearly these 2 coordinates are in the region of y, or the y-axis. It's above the x-axis, isn't it? So of course anything above the x-axis, anywhere here in the quadrant 1, quadrant 2, the y values, of course, they're positive. Okay, so you don't have to memorize it because there is an acronym to help you memorize this where they give you this chart here. They call it the ASTC. And notice they say sine is positive in quadrant 2. So they go ASTC. Sometimes they say the acronym is all student teachers crap. I'm pretty sure you can make up your own acronyms there. But that's essentially, I'm pretty sure there's other acronyms that I would have learned. That's the one I remembered when I was in high school. But this essentially is saying that in quadrant 1, it says A because all functions, so sine, cos, and I haven't talked much about tan, but tan is also positive in that region. I'll talk about tan much later. But what we can see is that sine is positive again, and it's called the S region because only sine is positive in the second quadrant. T for tan is only positive in this quadrant because remember, both sine and cosine are negative over here. But you'll find later that tan, which is the gradient, tan is also all positive in this region. So only tan is positive here, only sine is positive here, and only cos is positive here. You can memorize this chart. This is how it's normally taught. I don't like to. I just simply look at the unit circle and you can kind of figure out if sine represents the y values, well, y is obviously going to be positive in these 2 regions. That's the 2 points. Whereas if you had these 2 points, clearly y's are negative. So I don't memorize it based on the ASTC, but I memorize it based on the Cartesian plane. Whilst cos of theta represents x. So there should be theta there. Then x is only positive in these 2 regions here, because that's where x is positive, whereas over here, that's where x is negative. So it makes sense that quadrant 2 and quadrant 3, you expect cos to be negative. And then tan, on the other hand, we knew that tan is the gradient. Now remember back in year 9, you have 4 types of gradients. You have positive gradient, negative gradient, zero gradient, and then undefined gradient, right? Which is a vertical line there. You can see that tan is a positive gradient. So it looks like this in this region, so quadrant 1, and also in quadrant 3. That's why we say that since in this region here, both cos and sine, though, is negative, only tan is going to be positive. Another way also to think about it is tan, a theta, is equal to the opposite over adjacent, right? Which in a triangle, which means that it's y over x. But since y is your sine and x is your cos of theta, notice that sine is negative in that quadrant. So in quadrant 3, Sine is negative and cos is also negative, but we know that when we divide negative by negative, of course, it's going to be positive. So there's many ways to really try to understand this sort of logic as to where it comes from, right? So I want you to understand it from the unit circle perspective, understanding the sine and cosine. Okay, so that's the first thing to understand about sines. So you needed to understand in each section there's sort of a repetition around the unit circle, which one's going to be positive, which one's going to be negative for each of the functions. Now, today, I'm going to add on a second phase to understand. So you can pause the video here. This is 10 minutes of explanation about sines, as in whether it's positive or negative for sine and cosine. I want you to think about this for a moment, so you can pause it and just have a think about what I'm trying to say. I really need you to understand this concept of Q1, Q2, Q3, Q4, and why cos sine is positive or negative in each of the regions. Okay. Once you understand that, let's move forward. Moving forward, the next part that you need to understand is, okay, so now I understand that a unit circle has positives and negatives depending on, whoops, where'd it go? The x and y coordinates can be positive or negative depending on which region I'm talking about. So we've learnt about the region, we've learnt about what each and every one of those terms mean. So let's have a look here. Let's give an example. Let's say the angle that I make, okay, so let's go to this point here is an x and a y coordinate. The angle from the center to the point, so from here to here, remember the starting point is 0 degrees here. Let's say that was 30 degrees, right? Then I would draw a line. I would say, okay, so vertically, this will give me this height, which is a y value. So this means that y value is equivalent to, remember, finding the sine of 30 degrees, because sine is going to be the y values, right? So this is sine of 30 degrees. We know it's going to be a positive answer because clearly the y value is a positive in that region, or at least at that point. And then notice that the x value, on the other hand, so this is the x value, is the adjacent side. X is equivalent to cosine of 30 degrees. Okay. So cosine of 30 degrees will tell you the x coordinate, and sine of y value is equal, or sine of 30 degrees is equal to the y value. Now, on your CAS, I'm going to quickly do that just so that you know the value. I know the value, but I want you to sort of get used to figuring this out yourself. So here we go. I'm going to do sine of 30 degrees. Okay. Whoops. I realize my mode is in radians. You probably need it in degrees, so I'm going to change it to degrees. Gives you a half. Okay, so here we go. Sine is equal to half, and then cosine, okay, should be an exact value. Hopefully they keep it an exact value for me. We're going to do cosine. Good, root 3 on 2. So this is root 3 on 2. Good. So half and root 3 on 2. So what I'm trying to say there, so let's have a think for a moment. Okay, the x coordinate is root 3 on 2. Which means, I'm just going to draw it on the diagram again, just so you can see, which I'm trying to say, this length from here to here is root 3 on 2. Well, at least root 3 on 2 is right there, okay? So root 3 on 2, that's the x value. Then the y value, we know that the y value at this point is half, okay? Now, symmetry properties, exercise 14E, is trying to get you to visualize this in every single quadrant. You see, this is a 90-degree triangle. I'm going to draw the 90-degree triangle again. We've got 30 degrees, hypotenuse is 1, this is half, and this is root 3 on 2. Okay? That's our 90-degree triangle right now. The thing about 90-degree triangles, remember in quadrant 1, you can replicate this in the second quadrant. See, I can flip. If you imagine flipping this triangle horizontally, what you're going to get is something that looks like this. I'm going to make this a bit smaller so I can flip it for you to see. If I flip this across horizontally, okay, so I flipped it like this, this is what it's going to look like. Can you imagine where I have the same height, which is still 1, and I'm just flipping that triangle across. This is still 30 degrees. Same triangle, it's just flipped across. This is still half, and the length is still root 3 on 2. See, if I did that, can you see that when I replicate it into this diagram, this is where the next point would be. I would draw the line. This is still 1. It's still 30 degrees from this side. Okay, so from here up is 30 degrees. And we can see that the length from here, if it's still 30 and it's the same triangle, this should still be root 3 on 2. Except this time, it is negative. True, because it's in the negative x-axis. True, it's on the negative side. So this here should be negative root 3 on 2. Whilst the y value is still, this height, is still a nice positive half. So that means the coordinate at this point, if I asked you what the coordinate is, you would have said it's negative root 3 on 2 half. This is negative x, and that's positive y. Okay, so this is going back to the whole sign thing. We can understand now that this is what we call symmetry properties, meaning as long as you know the length of this side, you should also know the length of the left-hand side. But the angle's actually different. You see, we start off, I'm going to use a different color here, probably, let's use orange. From here was 0. Remember, this is 0 degrees. When here was 30. But if I went all the way across and I landed here, what's that angle there? See, let's think about it. Logically, if I went all the way from here, all the way here, that should be 180 degrees. True? So I'm going to draw it again. If I went from here to here, would have been 180 degrees. But we also know that I'm moving backwards. So from here to here, I'm moving up by 30. So what's the remaining angle? See, the remaining angle has to then be 150 degrees. True? So from here to here has to be 150 degrees. So what I'm trying to show you now is that when we talk about symmetry properties, before we said sine of 30 degrees, because that's the angle, right? We knew that was equal to half. What's interesting is the height, notice the height is exactly the same in both scenarios. This point and this point are the same. It's both half and half. This is the y value, that's half. The only difference was the angle, it's either at 30 degrees to get to that point, or 150, which is on this side with the same height. So what I'm going to say is on the calculator, you should expect sine, remember that's the y value, when the angle's 150 degrees, okay, it should be half as well, logically. Okay, so have a think about what I'm saying. So I'm going to draw the diagram again just to help you understand. This here says, when I draw an angle of 30 degrees, this height has a y value of half, or at least this coordinate is half. What's interesting is if you replicated that same triangle, but you drew it over here instead, and that's 30 degrees here, the height should still be half. True? It should still be half, except the angle now is 150. Starting from 0 here, going all the way there is 150 degrees. So watch, I'm going to type on my calculator. Have a look. We did sine of 30 before. That was half. But watch when I do sine, which is saying find the y value when it's 150 degrees. It's also half. Can you see that? And so this gives us a lot of room here. That means I can work around the unit circle multiple ways. So watch, I'm going to draw it again, just to get you thinking. This was 30 degrees. To get to this point, we knew sine of 30 degrees was half, right? So sine tells you the y values. So it was half there. Then I knew that if I went from here all the way here, leaving the same triangle, which means this is still 30 degrees, that triangle is exactly the same, it's just on the other side. This green angle has to be 150, because 150 plus the extra 30 will make a nice 180 degrees. So we knew that this coordinate here is still half, but this would be sine of 150 degrees. Now if I drew the same triangle again, okay, I drew the same triangle again, I drew it down this time, and this is 30 degrees again. So same triangle, still 30. That means the height, again, has to be half. True? So this point here should still be half, but what would the angle be? What would the angle be to go start from 0 all the way across here? You would hopefully now pick up that it is actually 180 degrees with an extra 30. So the angle would be sine of 180 degrees with an extra 30, means that sine of 210 degrees should give you the value of half, but what's the difference? Notice down here half, which is the y values are negative. It's in quadrant 3. So we know that sine of 210 should give you half, but it's a negative half. So watch, sine of 210 is negative half. See what I'm doing there? So that means I can also do the same thing into quadrant 4. If I went from the x-axis and I went down by 30 degrees, same thing again, went down by 30 degrees, I would have the same triangle again, which means that this height should still be half, but notice it's in the 4th quadrant, which is in the bottom region. The y value should be negative. True? Y value should be negative. So this, now what would the angle have to be if I were to start? So I'm just going to rub these out just so you can see. Starting from 0, and I need to go all the way across to land here. What would that angle be? Well, since I know this is 30, I only need another 30 to get to a full revolution, which is 360 degrees. That means this has to be 330 degrees. True? So sine of 330 you should expect it to be negative half. So watch, I'm going to go to my calves. I'm going to go sine of 330 degrees, and it's also negative half as well. You see what we're doing there? This is called symmetry properties. So we're using the symmetry of a unit circle. So what's symmetrical about the shape is we can replicate that in multiple regions. And the only difference is the height is the value in the sine. That's all it is. That's why you needed to know Q1, Q2, Q3, Q4, or understanding that each of these points, the y values are positive up here and the y values are negative. But the x values are positive on the right-hand side and it's negative on the left. That's it. Okay, so that's what this exercise is about. Now you'll find that they'll move from degrees. So I've been working in degrees with you, but eventually you have to work in radians. Meaning, your unit circle, what we were saying before, you need to eventually work with radians. So 30 degrees, I know, is the same thing as pi on 6, which I should actually write here. So this is pi on 6 distance. So 30 degrees, that's pi on 6. So if I were to draw that same triangle again on this side, this needs to be 30 degrees. I know I've drawn the angle a bit much more than 30 degrees there, but that means this distance here has to also be pi on 6. So that means at this point, if I were to calculate, remember all the way around is 2 pi distance. So that means from here to here is only pi distance. So if I wanted to know what the leftover distance is, meaning from here, starting from 0, how far is that? How far is this distance from here to here? Well, since you know that from here to here is already pi on 6, what's the leftover? Well, the leftover has to be pi minus pi on 6. This is where I was saying there's a lot of algebra for a lot of students, and using pi and fractions, that's where students get confused here. See, you know the distance from here to here was pi, true? And then you know that from here to here is pi on 6. So to get the remaining, you would then say pi minus pi on 6, which I know is 5 pi on 6, because I can do 1 minus 1 on 6. So for those who struggle with fractions, 1 minus 1 on 6, the trick that I do, I just simply do 6 times 1, 6 minus 1 is 5 on 6. So that's why I know it's 5 pi on 6. Okay? But this is where it's important that you were able to say sine of, let me go back again. Sine of 30 degrees was equivalent to sine of 150 degrees. I'm going to draw it again to help you remember. This was the triangle. 30 degrees was here. True? And 150 would be this point. So going all the way here is 150 degrees because I know there's a leftover 30. We need to understand it in a radian form as well. See, the radian form was that from here to here is pi on 6. Then to get the same thing over here, if this is pi on 6, then the remainder over here has to be 5 pi on 6. So that means on my calculator now, if I tried in radian mode, so those who don't know how to change their degree to radian, you can move your mouse to click there, or alternatively go to Documents and Settings and Document Settings, Angle, change that to radian, and you should be able to work in radian form. Okay, so watch. I'm now going to do sine of, and we're going to do radian form. So pi over 6, that's meant to be your 30 degrees. It's equal to half. Now watch. I'm going to do sine of 5 times pi on 6, and that also equals to half. Okay? Your job is to work with the radians and try to figure out where you are in the unit circle. Okay, so I am going to do an example right here. Let's have a look at this example here. It says here, sine of an angle, so we don't know what the angle is, but we know it equals to 0.6. If I asked you to sketch this, this is what they're trying to teach you. They're trying to say that I don't know what the angle x is, okay? But I do know sine, which is the y value, it is at 0.6. Now remember, the unit circle, the whole length is 1. So 0.6, maybe about here. Let's say 0.6 is there. So this is the point where the y value is 0.6. Okay, so the y value is 0.6, 0.6. This is the point, this is the angle. So I'm going to draw, we don't know what the angle is, it's angle x. So you got this nice triangle here, right? What they're trying to say now is find the value in part A. Part A, they want you to find sine of pi minus the angle x. So where is pi? So this is where 0 is. Pi was over here. Remember that? That's the distance pi. Now minusing means you're going backwards. But if you're going backwards by how much? You're going back by x angle. So that means I'm going to draw the angle x, and I'm going to get this point here. So I moved back by an angle of x. See what I'm doing there? I moved back by an angle of x. So it gives me this triangle. But notice that since these two triangles are exactly the same, this angle here and this triangle here have the same angle. So that means the height has to be the same. True, if this height is 0.6, well, this has to be 0.6. And we can see that the y value here, that must be 0.6 because these two they're exactly the same triangle. So to answer this question, I know this is the same thing as finding the sine of x because I know sine is the y value, and I know the y value is both positive in that region. Okay, and so that's why I know it's positive 0.6. You see that? Okay, so this is where I want you to practice drawing the unit circle and really getting your head around it. It's not easy for the first time. So let's do B. We want sine of pi plus x. Okay, so again, let's draw the unit circle to get our head around this. I'm going to draw the unit circle. So all we know is that from this point here, if the angle is x, okay, the height is 0.6. That's all we got, right? They're asking us find the sine, which means find the y value of pi plus x. So that's the angle. They're telling you what the angle is. Okay, so pi is going all the way here. That's pi. And then I'm adding on an extra x angle. Does that make sense? I'm adding an extra x angle from pi. So starting from this point, I'm adding an x. And you can see I will get this triangle now. But that triangle on the bottom is exactly the same as the triangle on the top because they both have the same angle and they're both 90 degrees. So that means if this is 0.6, this has to be 0.6 as well. But the difference is at this point, the y value is not positive. The y value is clearly negative. It's in quadrant 3. So that's why I know the answer, okay, if I were to write it properly, the answer for this has to be sine of pi plus x must be the same as sine of x, but the difference is it's negative. And so negative y value, which gives you negative 0.6. Does that make sense? Have a think about what I'm doing there. Okay, it's all about symmetry properties, but you're working with radians rather than degrees. And that's where it gets tricky. Okay, let's try another one. C. I'm going to do C. C is sine of 2 pi minus x. So again, where are you on the unit circle? So again, I'm going to draw a unit circle again. The only thing they've given us is they said sine of x. So x is, say, this is the angle x. They said sine, which tells me the y value. They told me that height is 0.6. That's all they've given me. Now, they want you to find where 2 pi minus x is. So again, where's 2 pi? 2 pi is all the way around. So 2 pi is over here. That's where 2 pi is. But from 2 pi, I'm minusing x. I'm going back this direction. So from 2 pi, I'm minusing x. So I'm minusing backwards by x angle. So that's why this is where my triangle is. This is x. I'm moving back by x. Okay? And so because they're both the same triangle, I can say this is also 0.6. But what's the difference between the two? Well, one's a positive y value, and this one is a negative y value. That's why you can say the angle here must be the same as negative sine of x. Also, the value is the same as negative sine of x, which is negative 0.6. Okay? So I'm hoping this helps you understand. And same thing with D. D, if we were to do D, it's about visualizing where you are in the unit circle. Sine of negative x. And again, that's the same thing. So if I drew the unit circle, see x is up here. This is the angle x. Well, negative x would just mean that you're going down. So anti-clockwise, right? But it's the same triangle. And again, notice that the position of negative x is in quadrant 4. So I know the answer has to be negative 0.6. Okay? So I'm going to pause there because I know the video is a bit long right now, but I'm hoping for you to understand, and you're only starting off by picturing where these are. Okay, so have a go with that. I will make extra videos to go along with it soon so that you can practice doing questions with degrees. It's the same idea where you work with sine and then you work with cosine. Okay, but this is probably a really important exercise. I'm going to make a video for this next. But that's just a class video to get you understanding what you're watching now. Okay, this is just to get the theory going, and I will make some videos for question 3, question 4, and maybe question 7 just to get you going. Okay.